Okay. With the potential energy to capacitor, suppose capacitor holds charge Q. What's the energy required to add a charge delta Q? Well, if you know the charge on the capacitor, you got to know something about the capacitor, right?
The area?
Maybe you know the area and the separation. And if there's a dielectric in there, what the dielectric constant is, right? Okay? And from that, you can figure out what the ratio of charge to voltage is. Okay? Well, that's called the capacitance. So, ratio of charge to potential difference, right? So, if you know Q, you find the potential difference, right? You just multiply potential difference by delta Q. Okay? Now to charge a capacitor, you do incremental charges. Let the charge be Qi star because we're partitioning the interval between zero charge and Q max, total charge. Okay? It's Qi star times C, which is the work now, this is a potential difference, right? Yeah, that's the charge you're adding. You multiply that, you get the work. So total work, you write a sum from I equals 1 to n of delta Wi. Of course, you'd write it out as Qi star times C delta Q. And this approaches as n approaches infinity, and your delta Q's all get small, the integral of QC dq, and oh man, I did something really bad. Knowing Q, you find the potential difference, right? Okay, this is a ratio of charge to potential difference. Okay? It follows the potential difference is Q divided by C, not Q times C. Fortunately, this is the only place I did that. Got to learn not to be careless, but I think it's hopeless. Now let's do this for delta Qi over C times delta Q. So it's Q over C dq, which is getting hard to read. And this would be from 0 to Q max. Okay? And what's that? Well, you can do that integral. Okay? It's okay, 1/2 Q max squared over C. And it's very straightforward. You don't really have to read this if you know how to go from here to the integral, and the integral is trivial. Okay? Well, that's the energy you got stored in a capacitor when its charge is Q max. And at any point, when you have an alternating current running through a capacitor or running through a circuit with a capacitor, this tells you how much energy you've got in that capacitor. So you know where the energy you're supplying when you crank the generator is, or where the energy is from whatever source, right?